Welcome, everyone. Thank you for coming to our session on how to train large models on Amazon SageMaker. I'm Rekha Sheshadrinathan. I'm a senior manager of product here at AWS, and I'm joined today on stage by my colleague Rama Thaman, who's also a senior manager on SageMaker. The two of us are very happy to be joined by Saad Godal, CTO of Hippocratic AI today. Saad and his team are using SageMaker to accelerate their model training, and he's going to share how they're doing that. So just a couple weeks ago, a bomb cyclone ravaged through the Puget Sound area. The storm brought with it hurricane-force winds that caused unprecedented damage to power lines, caused trees all over the city to fall down, and damaged roadways. The storm eventually left 500,000 households without power for several days. As many of us in the area tried to navigate through daily life without power, figure out how to talk to friends and family without cell phones, how to work without internet, how to take care of basic needs like hot water, and how to get around without being able to charge our cars, I got to thinking about technologies that have fundamentally changed how we live our lives and do our work. Whether it was the PC that introduced the power of mainframe computers into every household and introduced technologies like spreadsheets and document processing, or the internet, originally invented for military communication, but gave rise to things like e-commerce and video streaming. Or the mobile phone that put a computer, a GPS, and a camera into every person's hands. Do any of you remember the time when we used to actually print out directions from MapQuest and take them along? That used to be a thing. Well, we are very fortunate to be living at another historic time when there's yet another tectonic shift in the technology industry. Generative AI has taken the world by storm, and consumers everywhere have adopted it at a rapid clip. Now, here at AWS, we strongly believe that while there's a lot of excitement about how consumers are adopting this technology, it will fundamentally change how organizations innovate for their customers and employees. In fact, Goldman Sachs predicts a $7 trillion increase in GDP in the next decade through this technology. Now, at its core, generative AI is leveraging the latest innovations in machine learning and AI. With the advent of the transformer architecture, foundation models, or large language models, came to the fore. Now, what are foundation models? They're essentially very large models, often with billions of parameters, that have been trained on internet-scale data. And because of this pre-training exposure to a very large corpus of data, these models can perform tasks in a wide variety of contexts. Now, while the pre-trained models have many use cases that are exciting, the organizations that we speak to are also very excited by the ability to train such models on their data, which can be differentiating for their industries. Now, here at AWS, we have always worked backwards from customers. And about 5 years ago, when more and more customers started doing deep learning, we launched SageMaker Training Jobs. SageMaker Training Jobs provides a fully managed API for customers who want to train machine learning models without managing any infrastructure. Now, how this works is that you can simply provide us with the kind of instances you want, the number of instances, and a training script. SageMaker will take care of spinning up the cluster, downloading the required container onto the cluster, running your training script, and once the model is trained, we'll copy over the model artifacts to an output location of your choice. Once the model is trained, we automatically spin down that infrastructure, and you only pay for what you used. SageMaker Training Jobs is also integrated with experiment management tools, and it comes with warm pools for low latency, and is integrated with EC2 Spot instances. Because of the ease of use that Training Jobs provides, it continues to be a very popular choice for our customers who are training models and don't want to manage any infrastructure. But as we talked to more and more customers who were training large models for long periods of time, a new set of challenges started to emerge in the last couple years. The first one that we hear often from customers is about hardware. Now, in the last few years, there have been a lot of innovations in the hardware market with Gen AI. There are new chips coming out every few months that are allowing you to train models faster and faster. However, getting access to this latest hardware remains a challenge. And once you get access to this hardware, you also have to configure your clusters and all of the software to be compatible with it. And as the size of the models and the data sets that they're trained on gets larger and larger, we're also seeing that the compute needs for training models is continuously growing. In fact, it has grown over 4x every year in the last 5 years, which means that customers are needing to scale up these clusters further and further. And as the size of the clusters grow, so does the probability of infrastructure failures. In fact, in Meta's most recent paper on their Llama training, they mentioned that they faced one GPU failure up to every 3 hours, which is a lot of time that your data scientists are spending on debugging these infrastructure failures. And finally, as these compute needs grow, you want to make sure that your organizations are keeping their costs down and utilizing this infrastructure as effectively as possible. So to solve these challenges that we were hearing about, right here at re:Invent last year, Amazon SageMaker introduced HyperPod. SageMaker HyperPod is purpose-built infrastructure for Gen AI development that can reduce your time to train models by up to 40%, allowing you to scale across thousands of accelerators. How do we do that? So first, SageMaker HyperPod provides you with a resilient environment. What I mean by that is that the HyperPod clusters come with cluster monitoring software that are monitoring the infrastructure for failures and self-healing the nodes when a failure is detected, which reduces your time to train. HyperPod also comes with SageMaker's distributed training libraries, which allow you to easily shard your model and data across the cluster, making it faster to train on AWS infrastructure. And finally, many of the customers who are training these large models told us that they want a lot more control over the infrastructure. They want to be able to customize it and install whatever tools their teams needed. HyperPod allows you to SSH into the instances and gives you full control over the computing environment. So here are some of the core elements of HyperPod. First, on the infrastructure side, HyperPod leverages EC2 clusters. And essentially, you have EC2 instances that are on the same spine or availability zone, which is important for distributed training performance, that are connected via EFA or Elastic Fabric Adapter. This is a network interface that is specifically designed for high throughput and low latency. Again, very important for applications like HPC and distributed training, where there's a high degree of inter-node communication. You also have access to FSX for Lustre, which is a high-performance distributed file system. The HyperPod compute nodes run on the deep learning AMI, which comes pre-configured with NVIDIA CUDA and the latest deep learning frameworks. In addition, the HyperPod software also includes the distributed training libraries that are specifically optimized for AWS network topology and the cluster health monitoring software as well. So I'm going to go over some of the other key features of HyperPod. And later in the presentation, Rama is actually going to do a demo and show you how most of these things work. So first, in order to help customers easily create and manage these clusters, SageMaker HyperPod provides APIs through which you can create the cluster, update, as well as delete nodes. We're also fully integrated with the AWS console, so you can both create your cluster as well as access and monitor your HyperPod clusters through the UI. You can also do this through the CLI and CloudFormation templates as well. In terms of resiliency, like I mentioned, HyperPod comes with cluster health monitoring software that is constantly monitoring the cluster for hardware failures. And when we detect a hardware failure, we will either reboot the node, or in cases when that can't be done, we will replace that node from an AWS maintained spare pool of instances, which comes at no cost to you. And if you submit your jobs indicating that you want your training job to auto resume after a hardware failure, we'll also restart your training job and reload from the last saved checkpoint. So it's completely hands-off for your data scientists and machine learning engineers. And finally, to help you optimize cost and performance, we've also integrated with Amazon managed Grafana and Prometheus. So you can export your hardware metrics into a Grafana or Prometheus workspace and monitor your cluster utilization and make sure that you're using it as effectively as possible. Now, an important consideration for many organizations when they're considering their partners for GenAI is how quickly do these organizations move? Because we see that in this industry, there's a new innovation coming out every few months. Since launch of HyperPod last year, we've been continuously making updates. And one major update that I want to share is that just a couple months ago, we launched Amazon EKS support for SageMaker HyperPod. So when we launched last year, you could orchestrate your workloads using Slurm. Well, now you can also orchestrate your workloads using EKS. So you can either create a brand new cluster or attach HyperPod managed compute nodes to an existing EKS control plane. We've also updated the resiliency for HyperPod now. So when you create your clusters, you can optionally run deep health checks. These are nickel tests as well as DCGM diagnostics that you can run at the start, and that will reduce the probability of failures once you start your training. And finally, for EKS customers, we've also enhanced the scientist experience. So you now can submit jobs using a HyperPod CLI And we have Container Insights integration for utilization as well. With the launch of EKS, we're also seeing more and more customers use their HyperPod clusters for both training as well as inference. So if you're already using EKS to orchestrate your workloads, you can now use the same nodes both for model development and deployment, which can further optimize the utilization of your clusters. So with this intro to HyperPod, I want to hand it over to Rama, who's going to do a more technical deep dive and give you a demo of how all of this works.
Thank you, Rekha. In the next 20 minutes or so, I'll walk you through some of the technical details and also show you a demo of HyperPod. By show of hands, how many of you are training large language models or consider training large language models down the line? Okay, that's quite a few. All right, so let's start with training performance. Let's see how customers get training performance using HyperPod. HyperPod is specialized for training large language models and also foundation models. When training such models, you need to have specialized model parallel training techniques. For example, let me give you a scenario here. Let's say you're training an 8 billion parameter model. You will need about 160 GB of GPU memory. If you look at the latest hardware from NVIDIA, H100 has 80 GB per GPU, H200 has 140 GB. Now, for training an 8 billion parameter model, you will need multiple nodes. That's where you would need all of these techniques, and HyperPod comes out of the box with that. More importantly, what's important is the entire stack will have to be optimized to use your hardware and resources in an efficient way. Network bandwidth is super important. If you're training with tens of hundreds of nodes, these nodes are talking to one another very frequently. After every batch, you exchange the nodes. These are the gradients. Exchange the weights. These are the gradients. And if you have network bottleneck, then you cannot move faster. So you need to have a high bandwidth network. With EFA, you get 400 Gbps of network bandwidth. EFA doesn't, it bypasses the OS. It doesn't use TCP/IP. It uses something called libfabric. And EFA also uses NVIDIA's GPU Direct. It can do a remote direct memory access. The network card can access memory of another GPU. So that's how we get this high throughput. Then with libfabric, you get support for multiple message processing interface and also NVIDIA's common collective library. Storage is super important. If you're training a large language model, chances are you're using lots of data, and your training algorithm should be able to read this data faster. And to do that, you need to have a high performant file system where you have sub-millisecond latencies to read the data quickly. If you have to download the data onto your instance, then train, your GPUs are sitting idle. You don't want to have that. So you should be able to read data quickly. And with FSX, you can concurrently access thousands of instances and hundreds of thousands of cores. With all of these three things, customers are able to train faster. If they're able to train faster with less bottleneck and so forth, you could reduce the overall training cost. And that's how our customers are able to train up to 40% faster using HyperPod. Let's talk about resiliency. This is very, very important. Before you start your cluster, you should make sure your hardware is healthy. You don't want any hardware failures because that will slow you down further. To that end, with HyperPod, what we do is before we hand out an instance to the cluster, we make sure we run some deep health checks. We use NVIDIA's data center GPU management tools to run diagnostics. We pressure test the GPUs to make sure those are healthy. We also look at CPU health. This is important, especially when you're doing data loading. You should be able to use 100% of your CPU utilization and also have the I/O operations in good standing. We do that before the instances are given out. Once your instances are in the cluster, we continuously monitor the GPUs. We use the same data center management tools, and we monitor for certain thresholds, looking for certain errors, looking for threshold breaches for power and clock management and so forth, even temperature to some extent. So these are called policies, and these policies are set, and those are run continuously behind the scenes. We also use NVIDIA SMI to check the health of GPUs constantly and notify you. And network health check is also important. The health checker also checks for connectivity between the cards, between the instances, to make sure these instances can operate efficiently. Now let's look at the resiliency feature that Rekha talked about. You are bound to run into error, so you should be able to self-heal. With HyperPod, let's say when you start running training, you're constantly doing checkpoints. Large language model training usually runs weeks together, months together. You should be able to recover from errors automatically. So with HyperPod, what happens is, as you're training, if one node fails, HyperPod automatically detects the error, and it will take the node out of the cluster. It brings back a new node, does the deep health checks, and it will also pull down the necessary containers, then also the last checkpoint, and it will start training automatically. You see, we take the undifferentiated heavy lifting, and you don't have to worry about this. All of these things are done automatically behind the scenes. There are times where you may want to on-demand replace a node. Sometimes the instance may go into a state where they don't respond. So in those cases, you could on-demand replace a node. If you're using Slurm, you could run that command. If you're using EKS, you could use node labels to change the label, and automatically that node will get replaced. Ease of use is super important, given that there are so many open source tools, so many different options for you. We want to give you the flexibility to pick and choose the tools that you want to use. From an orchestration standpoint, we have managed EKS and managed Slurm that comes as part of HyperPod. If you want to deploy your own orchestration layer, let's say your own managed Kubernetes, you can do that as well. From a job submission standpoint, you could use Ray, Run AI, kubectl, whatever is your choice. For observability, we have support for Prometheus, Grafana, CloudWatch. And in some cases, you may want to connect to the cluster from a notebook or from your laptop. So from that, you can use SageMaker Studio or even use Jupyter Notebooks to connect to the cluster and submit training jobs and so forth. For training libraries, HyperPod comes with some of these popular training frameworks like PyTorch and so forth, with all the versioning and stuff, so that you don't have to worry about those. I talked about training strategies. We pack in all of the popular ones there. And with experimentation, we do have support for tools such as Kubeflow, weights and biases, MLflow, and so forth, so you could readily use it out of the box. We also provide first-party containers, like machine images, deep learning containers, and so forth, so you could easily pull down and start working on it. Device drivers, toolkits all come part of it. Hardware is super important. With HyperPod, you get the latest and greatest GPUs. From NVIDIA, we have H200, which is P5e, H100 is P5, and also our own silicon, that's the Trainium instances that are available as part of HyperPod. I touched on storage and networking. Now, let's go through the demo. Before I show you the demo, I'll go through the steps that I'm going to show you. First is preparation step, where you need to have certain resources ready before you can start the cluster, like your networking setup and so forth. Then I'll show you how to create a HyperPod cluster. As part of it, you can create a lifecycle script. So this script is used to set up certain things. If you want to install certain things in the nodes, you can do that. That's an optional step. Then I'll show you how to create a cluster config. Here you will set up the head node, the compute nodes. I'll also show you how to create different groups, like an inference group and another one for training and so forth. Then lastly, show you how to create a cluster. So up until this point, it's all admin setup. Mostly admins do it as a one-time step and so forth. And once you have the cluster, that's when your data scientist would come in. I'll show you how to run a training job, connect to a node to run diagnostic commands, then show you resiliency features. Here, I'll show you when I inject error into one of the nodes, I'll show you how HyperPod automatically replaces the node for you. Then lastly, observability. This is super important because you need to be able to monitor different metrics on your cluster like temperature, GPU utilization and so forth. So we have rich set of capabilities there. And for the demo, I'm going to use this workshop. I'll make this link available through in the end of this presentation. But with this, you can easily set up your Kubernetes, easily set up your HyperPod cluster, then test out and use the same config for your production. All right, let's go through the demo real quick here. So here's the HyperPod workshop I talked about. Yeah, you can test out different features here. I'm going to start with the prerequisite here. So here we are setting up some of the basic resources that you need. There are a couple of options for you. You could either do the full deployment where we would set up everything for you from networking and all of those things, or you could do integrative or minimal deployment setup where you could use your existing resources like networking and so forth. And for this one, I'm going to use full deployment mode. When I click on that, the CloudFormation template is going to set up all the resources that I need. You could go and change your availability zone, other details like the cycle rate and so forth. And once you create the stack, behind the scenes, we will create all the resources. You can see the EKS cluster is being created. Other networking resources that you need will get created automatically, like your VPC, your subnet, and so forth. This may take about a couple of minutes, but once that's done, you have all the resources that are necessary for you to create a cluster. So as part of creating a cluster, I'll show you how to create a lifecycle config. This is to set up whatever installations that you need or configurations that you want to make as part of the cluster. The steps are very simple. Create a script, put all the commands that you need, and you can save this file on the S3 location. Just copy it over, and we will reference this location when we create the cluster. That's how simple it is for the lifecycle config. Now, for cluster creation, there are a couple of options. Either you could use the CLI to create the cluster, or you could use the HyperPod console to create the cluster. For this demo, I'm going to show you how to use the HyperPod console to create the cluster. So here's the SageMaker console. You can navigate to the HyperPod console. It's on the left there. And once you go into cluster management, you will see the EKS cluster we just added here. I'm going to select that cluster. And now I can give a name for the cluster. I'll say demo cluster. And I can create different instance groups. One group for inference, one group for training. I can have heterogeneous clusters, different instance types and so forth. Here I'm going to use G5 instance. I'm going to have just one group. I'm going to have about 8 instances. I'm going to specify the location of my lifecycle script where it was. And I also will enable some of the resiliency checks that I talked about, the deep health checks. And I can use the advanced configuration to set up storage and other details that you may need. And here you can select the network that we created as part of resources. Then finally, when you hit submit here, behind the scenes, the cluster will get created. It may take 10 to 15 minutes, depending upon the number of instances that you have in the cluster. And here you will see, initially the instances will come up as pending state. Then we'll do the deep health checks for you to make sure the hardware is in good standing. Then the instances will go into a running state. shortly here. Now the cluster is ready and your data scientist can come and submit jobs and run training. I'll show you how to submit a training job. The workshop has different examples. Here I'm going to use PyTorch, a fully sharded example here. You can also alter this to change however you want, but here I'm going to use the training example as is. Using kubectl, I'm going to submit the job. You can see you could use the apply command. And behind the scenes, the job is being submitted, and you will see there are 8 workers. I can go look at which one is the leader node here by looking at the logs. And you can see the training has begun, the loss minimization is going on here. So that's how simple it is. You submit the job and the training starts. And in some cases, you may want to go into each of these nodes to figure out how your GPU is being utilized. So that's very straightforward. All you need to know is the node name that you want to get into. Then you can use AWS's session manager to connect to that instance. So you start the session, and once you're on, it's like any other EC2 instance. You could log in as another user, run commands that you need, like top command to look at all the processes. Also, you can run NVIDIA SMI to look at your GPU utilization and GPU health as well. So that's how easy it is to get onto an instance. Now let's look at the resiliency feature here. With resiliency, there are 2 scenarios here. One, HyperPod automatically replacing a node when there's an error. The second scenario is on demand. If you want to replace a node, you can do that. But for this demo, I'm going to show you how HyperPod automatically replaces the node for you. So here, I will have the setup of, so you can see I have the workers on one side and also the nodes on the other side. I have 8 different nodes. What I'm going to do is I'm going to log into the 3rd node there. I will do a SSM session there, and I'm going to inject error into the logs. So I write some error messages into the log. Then the HyperPod automatically picks up that particular node. You can see the 3rd node will go into a not ready state. And you'll also see that the worker will go into a pending state, and HyperPod will take that node out of that cluster. Then it'll bring in a new node, it'll do the deep health checks and so forth. And here you can see it added a new node for you, the 3rd one from the bottom. And once the node is added, it'll go through all the setup, like the downloading the container and so forth. And then once that's done, it'll also bring down the checkpoint to start the training where it left off. You can log into that particular node to see how the training is going. You can see that's a lot of undifferentiated heavy lifting. It's automatically done by HyperPod. You don't have to worry about it. Now let's look at observability. This is super important. When there are a lot of nodes, you need to be able to monitor for temperature, monitor for GPU utilization, CPU utilization, and so forth. Especially when you're training, you may not get the best utilization, so you have to go iteratively and you have to be able to monitor all of these things. So in the HyperPod console, you can click on Container Insights there, and that will take you to the observability page. And you can monitor metrics at the cluster level. You can see I have 8 nodes, the CPU utilization, I have high GPU utilization. That's what you want to see when you're finally done. You can see there are a lot of other metrics like amount of data that's going in and out to see how your network is being utilized. You can also monitor the temperature that I talked about. GPU temperature is super important to watch for, and a number of other metrics that you could leverage and set alerts and so forth. You can also look at pod level metrics. So you can see there are about 95 containers running. You can monitor at a granular level. Let's look at a GPU utilization here for one of the nodes. You can see there are 8 workers, and you could drill down to one of the workers that you want to see how GPU is being utilized. So you can see the rich set of features that are available for you. So far what you have seen is how to set up a cluster quickly, how to submit a job, then how to monitor, and also showed you the resiliency features. With that, now let me invite Saad Godel to talk about their journey of using HyperPod. Saad, take it away.
All right, thanks, Rama. Hi, everyone. I'm Saad Godel. I'm the co-founder and CTO of Hippocratic AI. Hold on, let me see. Let me go to my slides real quick. So let me tell you a little bit about Hippocratic AI and what we're doing. So we are tackling the worldwide nurse shortage by building Gen AI-based autopilot agents that can basically do clinical tasks. And what we're specifically doing here is patient outbound. So we'll call patients on the phone and be able to autonomously reach out and perform a task using our technology. Now, when we talk about Gen AI, there's many different ways that you can use the technology, right? And I think what you'll find is that a lot of Gen AI companies in healthcare are building what we call co-pilot solutions, right? So a good example of this is you'll see these EMR summarization, there's ambient listening. A lot of these products are basically targeted at helping a human in the loop become more efficient. The downside of this is, you're basically not able to get a lot of upside, right? You could at max, may improve someone's productivity by 10% or 15%, but that's not going to solve the nurse shortage that I was talking about. We need something much, much bigger leverage. And this is where the autopilot agents come in, right? These autonomous agents can actually fully do a task and will allow much, much larger scaling. And so what are some of the things that we do? So one example is like a pre-op call. So, you have a colonoscopy appointment coming up. We'll call you 3 days before your appointment. Make sure you start taking your bowel prep solution. Make sure you start your low fiber diet. We'll call you 1 day before the appointment and say, hey, now you got to stop eating solid foods. Make sure you start your clear liquid diet. And then, 6 hours before your appointment, make sure you stop drinking water as well. So, we can do all these, what I call care plan instructions and just communicate that with the patients and help them adhere to it. Another example is post-op calls. You just get discharged from a procedure. We'll call you up after the procedure, say, hey, have you had a chance to pick up your medications? Were there any complications? Did you have any questions about the care plan the doctor gave you that I can answer for you? And another big use case that we're seeing a lot of interest in is doing health risk assessments and annual wellness visit intake forms, where basically we can very efficiently get information from the patients at their convenience, and basically something that we think Gen AI can fully automate and do efficiently. But the most exciting aspect of this is really what we think this will lead to, right? So right now we're talking about tasks that we can augment and do ourselves, but we actually think as the cost of these calls goes to zero, we think it's going to unlock a whole plethora of use cases and care management that is not even done today, that we can't even think of. Right? And so this is actually what I think is the most exciting, compelling use of Gen AI. So a great example of this is, we had one of our customers come up to us and say, could we do a heat risk assessment? So heat waves are coming in. They can identify which of their patient population, subset of their patient population is most at risk. And we can just call all of them up instantly. Right? This is the power of Gen AI. You can infinitely scale it up as needed. Call them up every day, do a health risk assessment, make sure if they're at risk of suffering from a heat stroke, and we'll just basically transport them to a cooling center. Right? You can't do this with humans. You can't get enough people online at once, make all the calls. This is a perfect use of Gen AI. And so there's stuff like this that I think we'll be able to do that we just were not able to do before this was available. Now, one of the most important features that we have in our system is safety, as you can imagine. And the way that we do safety is we introduce this concept called constellation architecture. Turns out you can't do it with just one model. So our constellation architecture consists of 20 different models, or over 20 models. And we have a whole bunch of specialist models that work with the primary model to deliver the safe experience that we need. So we'll have a model that's just focused on over-the-counter, disallowed over-the-counter medication. There's a model that's just looking at your medications and making sure you're adhering to your prescriptions as required. There's a model that can do your lab analysis and give you the appropriate advice. So these specialist models allow us to train and specialize these models for these what I call safety verticals, safety axes. And for each of these safety axes, we can build a model that can deliver the level of safety that is required. Now, what we do is we train these models based on open source models. So we'll take the open source models, and then of course we'll train them with our, custom proprietary data sets. But the specialization is what allows us to get that last bit of performance to give the, to provide the safety that we need to provide. Now, very recently, we actually upgraded our constellation architecture. So we, first one was Polaris 1.0. We went to Polaris 2.0. And our largest model basically went from 70 billion parameters to 405 billion parameters. And that's a 6x increase in the number of parameters. And as you can imagine, we're a real-time application, right? We're calling patients on the phone, so latency matters a lot. And one of the big challenges that we had is when we upgraded these models, which actually was great because the reasoning capabilities that we got from the upgrade was significant. But it posed a real big challenge on inference and how do we maintain our low latency. And you'll see the plot on the right. This is a box and whiskers plot of our latency distribution. We actually were able to, through a bunch of very innovative, clever techniques, we were actually able to keep the latency the same. And so some of those techniques that we did, we did calibrated FP8 quantization. Usually when you quantize, you are trading off some kind of performance, but with calibrating it to our training set, we were able to actually basically not lose any of our clinical safety aspects that we cared about. We also did a lot of aggressive prefix caching. This is actually the key breakthrough. It turns out, when you're having a long conversation, your input prompt is very large, and that can take a long time to go process, especially for a large model. But the only thing that's changing from one call to the next is literally just the one patient turn that's been added. And so what you can do is you can leverage the prefill from the previous query. And then this is how you can actually save a bunch of time and lower the latency. And so aggressive prefix caching was critical. And of course, we're scaling up to many calls in parallel, so we have multiple nodes. And so if you're going to do any kind of caching, we also have to do some kind of routing to make sure that calls from the same conversation go to the same model. So we had some conversation-based routing as well that we had to add. Now, all of these models that I talked about were trained on SageMaker HyperPod. And one of the things about our use cases, because we're HIPAA compliant, and patient data is really important, we actually have a number of different clusters. So all of our production inference workloads that has sensitive patient information is actually run on a completely different account on a completely different cluster. And our training and all of the dev work that we do is done on a separate account. And so we basically use many different accounts for different environments to ensure that we have the right kind of data separation and security and privileges. And so this is kind of what our training cluster looks like. I think Rama and showed you a bunch of examples. So you'll see we're using a lot of the services that he talked about, right? So we're using FSX and S3 for our storage to get fast storage into the GPUs to train our models. We're using Grafana and Prometheus for logging and metrics. And as you can tell, these GPUs are fairly expensive, and we need to do extensive monitoring to make sure that our utilizations are good. And so we utilize all these metrics to ensure that we hit our utilization targets. Now moving on to inference architecture, it looks pretty much the same. You'll see that we don't have a lot of the user accesses because we don't actually give a lot of users access to our production clusters. It's very restricted. And the one addition that we have is, you'll see on the top, we have an application load balancer. And we actually use Kong as our API gateway manager because that's how our models will communicate to the application layer, is through the API. Now, I think a bunch of features I think Rama covered in his presentation, which we're definitely using. So first off, right, he showed you how easy it is to kind of spin up a cluster and spin it down. We love that, right? Because like I said, we have many different clusters, and being able to completely automate the spin up and tear down of a cluster is super critical. So we have Terraform scripts that will just go bring it up and bring it down as needed. Because we have multiple clusters, we're often balancing the needs between inference and training, between different kind of workloads that we have. And so being able to move these GPUs from one cluster to another is extremely important for us to be able to optimize and optimally use this limited resource that we have. And then of course, when we do that and we bring it up in another cluster, it's really great that HyperPod has these lifecycle scripts that will just set up the configuration of the node, and we don't have to do anything. We just bring it up and it's set up and configured correctly right from the get-go. And then of course, with GPUs, reliability is really critical, right? You will have faulty nodes, and being able to leverage the HyperPod feature where we can just swap out a faulty node with a backup reserved instance, it gets us up and running right away without wasting any time, which is a super cool feature. In terms of looking ahead, things that we are really thinking about, what's on our mind now is elastic GPU compute. When we're doing these kind of calls to our patients, it turns out there's really only 6 hours in the day where patients want to be called. And so, we're now working with AWS to figure out how can we actually get access to burst peak GPU compute. So we can actually scale up our inferencing workloads and hit all of our business goals. The other big feature, I'm really excited about EKS on SageMaker HyperPod, right? As you can imagine, our inference is scaling up pretty significantly. We need to do auto scaling both up and down to manage the complex workloads that we have. And so we need to basically automate all of our orchestration and all of the scaling up that I talked about. And so we think building it on Kubernetes with EKS is the right strategy. And so we're going to be investing in that and building that up next. Okay, and I'll kind of leave you guys with this idea, right? So from the beginning of time, healthcare has always been constrained by the healthcare professionals, right? The whole system has been designed with that kind of constraint in mind. And for the first time with Gen AI, we now can truly have abundance in healthcare. And that's really what Gen AI is going to help us go accomplish. And we're happy to partner with HyperPod and the SageMaker team to help us go deliver on this vision. All right, thank you.
Thank you. Before we wrap up, I wanted to leave you with some key takeaways. First, with SageMaker HyperPod, you can reduce time to train by up to 40% with the resiliency features and distributed training libraries that we offer. You can scale to thousands of accelerators easily using the APIs and console UI that we provide. You can optimize for cost and scale with the monitoring infrastructure that we provide, so you can look at utilization of your GPUs and CPUs. And finally, we are flexible. HyperPod is flexible and customizable, so you can SSH into the instances and customize the stack how you wish. Since launch, companies of all sizes and from all industries are leveraging SageMaker to accelerate their Gen AI development. These include top startups like Hugging Face, Perplexity AI, and Hippocratic AI, and enterprises like Salesforce and Thomson Reuters. And many of them are saying that HyperPod is saving them hundreds of hours in training time and improving their data science productivity. For those of you wanting to get started on HyperPod, here are some resources. Feel free to take pictures. And many of these customers are also in a customer panel, which is happening at 2:30 today. So if you want to hear more from Hopper AI, Hugging Face, or Writer AI, there's a session at 2:30, AIM 229, that I encourage you to attend as well. So thank you for attending and listening, and we'll be here to take more questions.